Today we want to work on trig substitutions. Say we want to calculate integral of square root, and under square root we have 16 minus x squared dx. We want to do trig substitution. X equals to 4 sine theta. Then the x becomes to 4 cosine theta d theta. So if we try to proceed with that substitution, what we're going to get, integral square root 16, instead of x we're going to put 4 sine theta squared, and instead of dx we're going to write down 4 cosine theta d. So in order to finish our theta substitution, we have to look at that expression under square root. So if you look at the expression 16 minus 4 sine theta squared, that equals to 16 minus 16 sine squared theta, so it equals 16 1 minus sine squared theta, so it equals to 16 cosine squared theta. That's my first observation. So now instead of having this guy, square root of 16 minus 4 sine squared theta, we have square root of 16 cosine squared theta. So what we have is 4 square root of square equals to absolute value of cosine theta. That's our first observation. But we also notice that x equals to 4 sine theta. We want x to be between negative 4 and 4. So we want sine theta to be between negative 1 and 1. So here we can assume that theta is between negative pi over 2 and pi over 2. Because we want to have x between negative 4 and 4, so we want to have sine theta to be between negative 1 and 1, and that corresponds to theta between negative pi over 2 and pi over 2. That means if sine theta is between negative pi over 2 and pi over 2, that means cosine theta between negative pi over 2 is going to be at least 0. So when we look at that expression back, absolute value of cosine theta will be just 4 cosine theta. So that will go instead of that square root. Alright, so if we do that, then we have simpler looking integral of 4 cosine theta times 4 cosine theta d theta. So we get 4 times 4 is 16, 16 integral of cosine squared theta d theta. Right? And if we recall their cosine reduction formula, then we should be able to calculate integral of cosine squared theta, so we get 16. And if we apply cosine reduction formula with n equals to 2, we get cosine theta sine theta over 2 plus integral times 1/2. 2 minus 2 is 0, so cosine 2 is 0 is 1 d theta. So distribute 16, so we have 8 cosine theta sine theta plus 8 theta plus c. So we're done with integration. Now we want to do back substitution. So I'll raise the intermediate steps. And now I'm going to look back on our substitution. X equals to 4 sine theta. So x equals to 4 sine theta. So sine theta from here equals to x over 4. So we can draw a triangle here. So theta. So sine theta equals to x over 4. So sine equals to opposite over hypotenuse. So missing side is going to be hypotenuse minus leg under square root using Pythagorean theorem. So square root of 16 minus x squared. So from here, cosine theta, looking at that triangle, will be, so let's try 8. So cosine theta will be adjacent over hypotenuse, so square root of 16 minus x squared over hypotenuse. Sine, so we already know what sine is, as x over 4, plus 8. Theta, you can find it immediately from here, sine inverse of x over 4. Don't forget plus c. Simplify that expression slightly, like 8, 4, and 4 on the bottom, but essentially we have our answer, so the final answer is going to look like 1/2 x square root of 16 minus x squared plus 8 sine inverse of x over 4. To summarize, if we have integral and we have expression here, an expression inside of integral has something involving square root of a squared minus x squared. So something involving a expression square root of a squared minus x squared. What we want to do, we try to do trig substitution, and our trig substitution is going to be x equals to a sine theta. So here we are assuming that a is positive. Then dx is going to be equal to a cosine theta d theta. And that expression, square root of a squared minus x squared, will become, after doing something similar to what we did with, on our previous example, we're going to get a cosine theta. So that's a piece of information we're going to use. So we're doing substitution x equals a sine theta, we use dx equals a cosine theta d theta, and we use the way to get rid of square root, that square root of a squared minus x squared under square root is going to be a cosine theta. So let me run one more example.